Hello, I'm going to work out an example from the Connect Math homework, which is section 8.3, and this is, I guess this is question number 5. The question is sleep time. The question focuses on sleep time. A person read that the average number of hours an adult sleeps on Friday night through Saturday morning was 7.3 hours. So this is something of a population. So when we're going to get started on this, this is our mu of a population, 7.3. That's what I'm going to put in there for a population. Okay. Now we have the researcher feels that college students do not sleep 7.3 hours. So do not, that means that if your null is going to be status quo, that mu is 7.3, the researchers claim the alternative is going to be that it isn't 7.3. And that is my claim. All right, that's what I'm going to put for the claim over here. All right, so the researcher feels that this is a hunch. This is something that he has or she has, and they want to check it. The researcher randomly selects 17 students and found, okay, so we have here n equals 17. And let's see what we find. We found on average that they slept 8.5 hours. This is the X bar of your sample. 8.5 is for your sample. The standard deviation of the sample, again, this is for the sample, so this is not sigma, this is S of X, is 1.4 hours. Now, at alpha equals 5%, so we also have a significance level of 5% here, alpha is 5%. Is there sufficient evidence to say that college students do not sleep 7.3 hours on average? Assume the population is approximately normal and use p-value method and tables. So part A asks, state the hypothesis and identify the claim. I actually did that here as I was reading the question because that was something that was presented to us, that this was the feeling the researcher had. Second part says, part B says, compute the t-test, compute the test value. Now, how do I know to go to the t-test value here? I know that because I was not given a sigma, I was given here a sample mean, and I was also given a sample standard deviation. The fact that you have sample standard deviation is the fact that it's going to result in a t-test for us. Okay, that's how I know that I should be using here t. The t-test is going to be computed by the mean of the sample minus the mean of the population divided by the S of X divided by square root of n. And this is exactly what I'm going to do here. I'm going to grab all those numbers that I found from here and put them all into my t-test statistic. So my t is going to be 8.5, as I know that these college students on average slept 8.5. minus the population, 7.3. Now I'm going to divide that by my standard deviation, 1.4, and then I'm going to divide that by square root of 17 because I was given that the sample size was 17. Let's put this all into a calculator. Okay, pause if you need to. Let's put this into a calculator and we should come up with 3.53. Okay, now we need to go and find the interval for the p-value. So t-tables are not as detailed as your z-tables. So when you're going to open your t-table, whether it's in the book or online, you're going to see over here that your t-table essentially doesn't have all of them. It only has certain levels, okay? So remember over here, our hypothesis is a two-tailed hypothesis, okay? So we are going to be using this bottom row. And I also know that my degrees of freedom is going to be 16. So I need to be in the row that has 16. So there is my row of 16. And I'm going to go and find my 3.53. So this one over here is 1.37, 337. No good. Continue going, continue going. These are all too small, too small, too small. I end up here, which says that each tail is less than 1%. Okay, each tail is less than 1% because my value is more than 2.9. My value is actually 3.53. That's going to be beyond that. So the probability of being there is even smaller than 1%. All right, so I know that my range for my p-value range is going to be less than 1%. The probability of something like this happening is less than 1%. Okay, so since the probability of getting such an extreme value is less than 1%, even if I have two tails, remember this is a two-tail test, even if I have two tails, that means that even if I were to double this, 1% for one tail and another percent for another tail, it's still going to be less than my significance value. Okay, so I get less than 2%, and that's going to be less than 5%. So my p-value, you can see what I'm writing, my p-value is less than my alpha, which is 5%. Okay, my p-value is about 0.02%, even actually less than that. No percents here, sorry, I wrote this as decimals. Okay, so my p-value is actually less than my alpha. If my p-value is less than alpha, that means that I'm far away from the mean. If I'm far away from the mean, that for us is an evidence to reject. The probability is very, very small. You are far from your hypothesized mean. That is an evidence that the alternative must be true. Okay, even if you double it, it's still going to be a very, very small value. Right? So this is for us evidence for or in favor of the alternative, for alternative. Oh, so I can essentially reject my null, right? Because the last part says make a decision. So I can reject my null, all right? So D, we can reject null. And remember that my claim was on the alternative. And thus, we have sufficient evidence in support of the alternative, in support of our claim. The claim was that college students do not sleep 7.3 hours. It did appear that it was really far away. It was beyond our threshold. It was really far away from the mean. Therefore, it is an evidence in favor of our claim, in support of our claim. Again, we could be making a type 1 error, but it is right now, this is where it is. It's in a significant place.